Good morning. Next is structure of amino acid. Structure of amino acid. First we discuss amphoteric nature of amino acid. Amphoteric nature of amino acid. So the main heading is structure of amino acid. Under structure of amino acid, we discuss the amphoteric nature of amino acid. We know that amino acid contains acidic functional group and amino group. That means both acidic group and basic group are present in the same molecule. Therefore, amino acid can exist as ionic form. Okay, that is what is known as that ionic form is known as below that. Okay, in amphoteric nature of amino acid we discuss sweeter ion formation. Sweeter ion formation. So first we discuss sweeter ion formation. As I told you, amino acid contain both acid functional group and basic functional group. Because of these two functional group, acid and base functional group present in the same molecule, this amino acid can exist in the form of an ion, which that ion is known as a sweeter ion, or it is known as dipolar ion. Another name is a dipolar ion. So look at here. The general formula of amino acid is RCHNH2 COOH. Now you can see that there is a acidic functional group and a basic functional group. Both are present in the same molecule. Due to the presence of these two functional group in the same molecule, look at here. We know that acid means so the same thing can be written like this: RCHNH2. COH means it will be in the form of a CO minus and H plus. This you know, because this acid will be in the form of CO minus and H plus, can change in the form of CO minus and H plus. So now what is happening? You know that this NH2 group is a basic group. That means the lone pair of electron is present on the nitrogen atom. What will happen? This lone pair electron present on the nitrogen atom will abstract this proton from the COH group. So what will happen? It will be changed into CrCH. Since NH2 group is abstracting a proton, what will happen? By using the lone pair electron of nitrogen, so what will happen? Nitrogen will get a positive charge and it will change into NH3. Correct? This will change into NH2 and NH3, and of course since this lone pair of electron is utilizing for making a bond, it will get a positive charge, and this part will be changed to COO minus. That means you can see that a positive and a negative ion are present in the same molecule. This structure, this is the sweeter ion form of what is this one? This is the sweeter ion form of amino acid. Sweeter ion form of amino acid. Sweeter ion form or dipolar ion form of amino acid. Very important. We discussed the structure of amino acid. In the structure of amino acid, the first heading is amphoteric nature of amino acid. In order to explain amphoteric nature of amino acid, first we discuss sweeter ion formation of amino acid. Listen here. Amino acid will always exist in the form of a sweeter ion due to the presence of acidic and a basic group present within the same molecule. The acid will donate a proton and the base will accept that, and we will get a ion like this. This ion, that means a positive charge and negative charge is present within the same molecule. This ion is known as the sweeter ion. Since amino acid is existing as a sweeter ion, this amino acid is a high melting water soluble crystalline compound. Since it is existing in the form of a sweeter ion, it is a crystalline, colorless, high melting compound or high melting substance. Okay, due to the presence of or due to the formation of sweeter ion, the amino acid can interact with both acid and base. Therefore the amino acid is having a amphoteric nature. So why amino acid is having an amphoteric nature? Because in amino acid there is a positive part and a negative part. Therefore amino acid can interact with both acid and as well as base. There, that means amino acid is showing amphoteric nature. Okay. Next point, so when we discuss the structure of amino acid, first you have to explain the zwitterion formation of amino acid. Next point you have to explain under the structure of amino acid is isoelectric point of amino acid. So next is, so first one is zwitterion formation, next is isoelectric point of amino acid. Isoelectric point of amino acid. Okay. Now what do you mean by isoelectric point? Depending upon the pH of the solution, it's very important, depending upon the pH of the solution, the zwitterion form of amino acid can accept or donate a proton. So once again, under or depending upon, so I can write depending upon the pH of solution, what is that? The zwitterion form of amino acid, the zwitterion form of amino acid can donate or accept a proton, can donate or accept a proton. So look at it here. So our amino acid is R CH NH2 COH. Okay. So depending upon the pH of the solution, so we can say at we are taking the zwitterion. Okay, this is amino acid. So look at it, depending upon the pH of the solution, the zwitterion form of amino acid. So what is the zwitterion form of amino acid? NH3, here it is plus, and here it will be CO minus. Okay. Now I can take low pH, depending upon the pH. Now I am taking low pH. What do you mean by low pH? If I take consider the pH of the amino acid or the zwitterion pH is below 7, that means low pH means it will be in the form of acidic form. Okay, that means acid medium. That means what is present? H plus is present. Low pH means acid medium, H plus is present. In low pH, what will happen? That means in acidic medium, the zwitterion, what will happen to the zwitterion? The zwitterion, this CO minus will abstract H plus, this will abstract, CO minus will abstract H plus from the acid medium, and what you will get? We get RCH, here it will be NH3 plus, no change, and here it will become COH. That means there is no negative charge, only the positive charge. That means at low pH, what will happen? We will get a cation. What is that? This is a cation. This is only the positively charged ion we are getting, that is a cation. Low pH cation. At a low pH we get a cation. What do you mean by low pH? Low pH means what is that? Acidic medium. Acidic medium means below 7. That is low pH means acidic medium. In the acidic medium, what will happen to the zwitterion? The zwitterion will accept a proton from the acid and it will change into a cation. Now at a high pH, now next condition is a high pH. What do you mean by high pH? High pH means basic medium. Okay. Basic medium. In basic medium, what will happen? Look at it here. Basic medium means OH minus is here. Okay. Basic medium. In basic medium, so this acidic medium, H plus is subtracting, and here it will become COH. In basic medium, what is happening? This OH minus will abstract a proton. So NH3 can be written as a NH2H. This OH minus will abstract a proton from here. Okay. So what you will get? We get RCH. Here it will become NH2. But here what is that? Here it is COO minus. So what ion is this one? This is anion. We get anion. Once again, high pH. So first one is low pH. Low pH means acidic medium. Acidic medium, this part is no change for NH3 plus. It will be like that only. And what will happen to CO minus? CO minus will abstract H plus and it will change into COH. Now at high pH, that means in basic media what will happen? This CO minus, no change for CO minus, it will be like that only. From NH3 plus, what will happen? One proton will be abstracted by the base OH minus and it will change into H2O, and what will happen? We get RCHNH2 COO minus. There is no change in here. So here it will become, what will become? Negatively charged ion, that means anion, and here it will become cation. Okay, that means depending upon the pH of the solution, once again depending upon the pH of the solution, correct? The switcher ion can of form of an amino acid can donate. See here it is donating a proton and it will change into anion, or accept a proton here, accepting a proton and it will change into a cation. Okay, this is the, if there is a low pH and high pH, this change will occur. Now if that means at low pH, if this solution is subjected to electric field, subjected to an applied electric field, what will happen to this cation? That means at low pH, what will happen? This will be migrated to the cathode. That means the switcher ion at low pH, the switcher ion will be in the cation form. Therefore, at low pH, in an applied electric field, the switcher ion will move towards the cathode, because at low pH, the switcher ion is having a positive charge. At low pH, the switcher ion is having a positive charge. Therefore, in an electric field, if there is a cathode and anode, at low pH, of course, this will move towards the cathode. Okay, so low pH, it will move towards the cathode, because at low pH, it will exist in the form of a positive ion. Definitely, it will move towards the cathode. And at a high pH, it will have a negative charge. That means it is an anion. At a high pH, what will happen? It will move towards the anode, because the negatively charged ion will move towards the anode. So the first you keep it in mind. At low pH, the switcher ion is in the form of positive ion, so it will move towards the negative electrode, cathode, and at a high pH, it is having a negative charge, therefore it will move towards the positive electrode, anode. Okay, this is happening at low pH and high pH. Now we are coming to our isoelectric point. And at a particular pH, not low pH or high pH, at a particular pH, we can see that there is no net movement of the switcher ion form towards the anode or cathode. This pH is known as isoelectric point. Once again, at low pH or high pH, it will move towards the electrode. Okay, at low pH, it will move towards the cathode, and at high pH, it will move towards the anode. But at a particular pH, not high or low, at a particular pH, we can see that there is no net movement, there is no movement for the switcher ion towards the anode or towards the cathode, or we can see that at the pH at which the switcher ion will not carry any charge, the switcher ion will be neutral, and there will not be any preferential movement towards the cathode or anode. That particular pH is known as isoelectric point. So that also I can write what is isoelectric point, the exact definition for isoelectric point. Okay, so the pH at which the switcher ion carries no charge, and hence will not show any preferential movement, towards cathode or anode. It will not move at a particular pH. The sitter ion will not move towards the cathode or towards the anode. That particular pH is known as isoelectric point. Okay. So that's all about isoelectric point and structure of amino acid. So under structure of amino acid, you have to explain sitter ion formation and isoelectric point. Okay, thank you. We continue in the next class.